Okay, number 21. Let's go ahead and find f plus g of x, which is f of x plus g of x. Your f of x function is 2x minus 1, and g of x is negative 2x squared. And I'm just going to put this in the correct order, in descending order, negative 2x squared plus 2x minus 1. And our domain is going to be negative infinity to infinity. Both of our original functions have a domain of all real numbers or negative infinity to infinity, so the overlap or intersection is all real numbers. Okay, so now we have f of x minus g of x, and that is 2x minus 1 minus negative 2x squared. And then you get 2x minus 1 plus 2x squared. I'm going to put that in descending order. 2x squared plus 2x minus 1. And the domain, negative infinity to infinity. If you properly find the domain for f plus g of x, then you already have that domain for minus g and times g. I can even fill it in. Look at that. So now I'm going to do f of x times g of x. Once again, I just said it has the same domain as plus and minus g of x. And f of x is 2x minus 1, and g of x is negative 2x squared. And you have to distribute your negative 2x squared throughout both of these terms. I prefer to have the smaller polynomial first when I'm distributing, so I'm going to switch them. Not that you have to, it's probably a waste of time, but I'm doing it anyway. So we have negative 4x to the third plus 2x squared. Let's go ahead and do, I don't know, let's do f of x times f of x. Why not? F of x is 2x minus 1. So I have 2x minus 1 squared, or 2x minus 1 times 2x minus 1. So that's 4x squared. Minus is going to be minus 4x, and then plus 1. I actually do better if I see it expanded out. I don't do so hot with this in my head completely, but hopefully I did that correct. And our domain is going to be negative infinity to infinity. The overlap of both of these domains, and it's the same function, so the overlap is itself negative infinity to infinity. Okay, let's go ahead and do f of x over g of x. F of x is 2x minus 1, and g of x is negative 2x squared. Okay, so the domain is the overlap except what makes the denominator equal to 0. It's the intersection of the two domains of the original functions except what makes the denominator equal to 0. So our original domain, or the overlap, is all real numbers, and we're going to take our negative 2x squared and set it equal to 0. And we are going to divide by negative 2. You get x squared is equal to 0. Square root both sides. You get x is equal to 0, and that's what x cannot equal. So we're going to remove that point, and there'll be an open circle there. So our domain goes from negative infinity up until 0, union with 0 to infinity. And then lastly, we have g of x over f of x. G of x is negative 2x squared. F of x is 2x minus 1. And their original intersection is negative infinity to infinity, the whole number line. We need to figure out what makes our denominator equal to 0. 2x is equal to 1, x is equal to a half. And that's actually what x cannot equal. So we're taking it back out of our domain, and that number's got to go. So we are from negative infinity up to 1/2, union with the other side of 1/2 to infinity.